Start by reading and summarizing the question. It essentially asks, what is the longest wavelength of light that can be emitted from an electron in the n=4 energy level of a hydrogen atom? Longest wavelength of light is the same as saying the radiation corresponding to the lowest energy transition, and the fact that light is emitted means the electron must be dropping to a lower energy state. In other words, n final must be smaller than n initial. Note that since the question only asks about the resulting electronic state, the first sentence is useless, except to tell us that the electron is currently in the n=4 state. Now that we've understood the question, we can make a summary of what we plan to do. The lowest energy transition from n=4 is n=4 goes to n=3. Use the Rydberg equation to find the wavelength that corresponds to this transition. First, rearrange the equation to solve for wavelength, and remember that the Rydberg constant is 1.097 times 10 to the 7 in units of inverse meters. Since the question doesn't specify what units the answer must be in, we don't need to worry about converting any units. Now we can solve the question. Plug in the value for the Rydberg constant, 1.097 times 10 to the 7 in units of inverse meters, and the two values for n. Remember, n1 must be smaller than n2. And calculate the answer. Finally, check your work. Have you included the right number of significant figures? Does your answer seem reasonable? The wavelength we calculated falls in the infrared region of the light spectrum. Infrared radiation is of lower energy than visible light, so that's a reasonable answer.